All right, let's talk about refraction. So we've got a closed shape here. We always assume that a closed shape is more dense inside than it is outside. So outside we assume is air, and inside the closed shape, maybe glass or plastic, something more dense, so that when light goes into it, it's going to slow down because that light is going to be interfered with the particles that are inside, far more than outside with the air. So let me start by drawing a light ray heading straight into the shape. So if we have it straight into the shape, what you'll notice is that the surface that it's going into is approximately 90 degrees to the light ray. And because it is, that light ray is going to pass right straight through this thing, okay? Because it is going straight through, or it's 90 degrees to the edge that it's going into. So anytime you have any light ray going um, at a 90-degree angle to the surface that it's going into, it's going to go straight through, right on the normal line. Okay, things are different now. If you have another light ray, let's draw it in a different color here, another light ray that is going in at an angle, let's say like this. Well, if it's at an angle, then we have to actually, we don't need a tangent line, but we need our post-it note here so that we can draw a normal line. So let's approximate a normal line. Let me get out my pen. Sometimes these tools on the iPad are kind of tricky. There we go. There's our normal line as best as I can draw it on this thing. And well, we know that when light goes into an object, it slows down. But if you think about the marching band example or analogy that you were given, when the marching band's going into this, the ones that are on the right side, these two that are on the right side, are going to slow down first. It's because those two are going to slow down first, and the two on the left side, these two, are going to still go at the same speed and slow down last. It's going to turn upwards. In other words, anytime light goes into an object that is more dense, it will slow down and it will bend towards the normal line. So since this is the direction that that light is headed, it's going to slow down and it's going to bend towards the normal line. This is the normal line that you see. This dashed line is the normal line. So it's going to bend towards the normal line. So we can't draw it like this. We have to draw it bending towards the normal line, which is something more like that. Okay, so now that it's reached this side, we're going to take our post-it note. We're going to take our post-it note and drag it over here. And let's rotate this a bit so that it fits along the edge of our surface. And then I'm going to draw the new normal line on this side, like that. Okay, now I can take this away. And when it goes out of the shape, it's going to speed up and go away from the normal line. So again, you can imagine the marchers going along here. The ones on the right are going to speed up first because they go outside first. And so it's going to turn downwards. Or in other words, anytime your light ray goes out of a shape, or I should say, anytime your light ray goes into something less dense, all right, it's going to go away from the normal line. So this is your light ray. This is the direction it was headed. It's going to go away from the normal line. The normal line's here. It's going to get away from the normal line. Okay, I just made a huge mess. So I'm going to erase that. And then let's go back to drawing away from the normal line. So it's going to go this way. Okay, so approximately that's what's going to happen. When you have your green light ray, it goes into the shape, it's going to go towards the normal line. I'm just drawing arrows to show you it's bending towards the normal line. And when it comes out, it's going to go faster, and it's going to bend away from the normal line. Okay? Okay, we're going to take a look at a different shape. I'm going to draw a circle. It doesn't matter what shape, it's all the same. But I'm going to draw something circular. Not a perfect circle, it doesn't really matter. And I'll show you that it's just the same thing. You just have to do the same things. If I have a light ray going into the circle, let's say this way, well, first of all, because it's a curved surfaces are made up of tons and tons of flat surfaces. So we just need to find the flat surface on this curve here. So that's called a tangent line. So to draw a tangent line, we need to find out where that light ray hits the curved surface and draw a line right at that point. So I'm going to go ahead and draw a line that only touches that point. Pretty good. So that is called my tangent line. Tangent lines are straight lines, flat surfaces that only touch the point where the light ray hits the curved surface. So there's my tangent line. Now to get my normal line from that, and then we draw a tangent line so that we can create a normal line. So I bring over my post-it note right here, line it up, and now I can draw my normal line, which will be something like this. Okay, so I'm done with my post-it note. I can move it away. And so now that I've drawn my normal line, I'm going from air to the inside of this shape. So the light's going to slow down because we assume the inside of the closed shape is more dense. So the light's going to slow down. And when it slows down, it bends towards the normal line. So this is the direction it's headed. It's going to bend towards the normal line. So let's erase that and draw how it's actually going to appear. It's going to go this way, towards the normal line. All right, let's finish this off on the other side. On the other side, we have another curved surface. So that means, again, we have to find out what the flat surface looks like at that point. And so on this side, we need to draw a tangent line. So I'm going to approximate a tangent line that only touches that one point. So there's my flat surface. Bring over my post-it note. Okay. Then let's draw our normal line. Something like that. Okay, so now the light comes out. When the light comes out, it's going to speed up because it's going out into the air. There's fewer molecules in its way, fewer particles in the way interfering with it. So if it went straight through, it'd be like this. But since it speeds up, it's going to go this way, away from the normal line. So let's draw this part properly, how it's actually going to go. I'm going to draw it going away from that normal line. All right. So that's how it should look for the circle. Alrighty, let's try a different shape. How about something we've seen in class in our labs, which is a biconvex lens. So now when we're talking about reflection, we always talk about mirrors. When we talk about refraction, it's always about lenses because it's about light passing through things And we've ingeniously created these lenses that help correct our vision, that help magnify things, to help us see the stars, that help us see tiny bacteria. Um, so lenses are very useful to us. But it's, if you look inside any animal's eye, you will see a lens as well. So it's something that we've created, but also it exists in nature, something that will focus light so that vision can be accomplished. So I'm going to draw a biconcave lens. Let's see, looks like this. It's concave on both sides. Biconcave. Okay, now let's draw a ray through this. Let's draw going this way. And so now I need to draw, because this is going through a curved surface, we need to make a tangent line before we can make that normal line. So I'm going to estimate tangent line probably looks something like that. And I'm going to grab my post-it note here, turn it a bit, line it up here so that it's lined up with my tangent line. Okay, and then make the normal line. Oops, I have to switch pens. This is actually trickier than writing on the whiteboard because I have to keep switching tools and things like that. Okay, so there's my normal line. And because my light ray is going into something that's more dense, it will slow down and bend towards the normal line. So it'll bend this way. Oh, I don't know if you can see this, but it's bending downwards towards the normal line. Okay, and now when it reaches the other side, just quickly draw a tangent line. Pick up my post-it note, line it up, make it super huge, why not? Okay, and normal line is, oopsies, tricky. Okay, forgot to switch pens. Man, this is, okay. Here's my normal line, something like that. Get this out of the way. And then now, because it's exiting like this, and it's going into air, it's going to speed up and go away from the normal line, away from this normal line. Of course, we don't want to leave like that. Let's erase all that and show it actually going away from the normal line. Okay, and the same thing will happen at the top. In the middle, as we know, because this middle part, the surface, the tangent line is actually perpendicular to the light ray. So if the light ray is going through dead center, it's going to go straight through. And then on the very top, tangent line, I'm just going to forget about the post-it note, but you guys should use your post-it note to draw your normal line, because until you get used to seeing a 90-degree angle, the light ray will slow down, go towards the normal line. So in this case, it's going to go up. It's not always up. It goes towards the normal line. There's my tangent line. There's my normal line. And this light ray is going to go away from the normal line as it comes out. So you can see what a biconcave lens does. Light that goes in will bend like this, bend like this, so it'll spread the light out. Okay? And if you did the lab in class with the lasers, you will actually see that. It bends it outwards. So anytime you want a corrective lens and you want to correct the vision so that you spread out the light rays, then you want to use one of these. Okay. Okay, so let's draw a biconvex lens. This is the type of lens that you find in your eyes and your sheep's eyes. Oops, let's make this nicer. something like this. Okay, I'm no Bob Ross. Okay, so we have a light ray. If it goes straight into the middle, because the tangent line is perpendicular to the light ray, it's going to go straight through. However, if the light ray goes into the top part, now our tangent line is more like this. And if we draw our normal line, again, I'm just going to be estimating my normal line, but you guys should definitely use your post-it note. My light ray, because it slows down, it's going to bend towards the normal line, this way. And when it comes out this side, oh, that's not a very good normal line. Maybe I should use the post-it note. That's where it should go. Okay. Light ray comes out. It's going to bend away from the normal line. Oops, did I just make that light ray curve? It's not supposed to happen. Okay. And similarly, on the bottom, tangent line is here. Normal line is approximately there. That's not very good. Let's do it better. 90 degrees. That's more like 90 degrees. Okay, light ray goes in, but it's going to bend towards the normal line because it slows down. Now on the other side, it's going to bend away from that normal line. So at some point, they're all going to focus on one focal point, which is what your lens does in your eyeball. It and the cornea, actually, both of them are shaped such that they will focus light so that by the time it gets to your retina, let's see, your retina is right here, all that light, all that light reflection coming off objects around you will be very clear because it's focused on the rods and cones in the back of your eye. Okay. Okay, finally, I'm going to draw some random shape, like, yeah, something like whatever this is. A blob. So for my blob, I haven't practiced this, so I don't know what's going to happen, but I'm going to draw a line going this way through my blob, and you just basically do the same thing. I could give you any shape. If there's a curved surface, this looks pretty flat actually, but if there's a curved surface and you draw a tangent line, and you bring over your post-it note or whatever square you want to use. Ah, what happened there? It's not good. Like that. Draw your normal line. Mm, mm, mm. Okay, get rid of that. And then think to yourself, well, if it's going into the blob's obviously more dense. So if it's more dense, then it's going to slow down. The marchers will slow down and move upwards towards the normal line. In this case, it's not always upwards, but it's always towards the normal line. So since this is the direction that it's going, right, it's going to head towards the normal line because it's going to slow down. So let's erase that and draw it going towards the normal, bending towards the normal line. So it's going to go up this way. Okay, let's see what happens when it reaches this edge. we don't really need a tangent line here because it's pretty flat here. Okay, but there it is. Our normal line is going to be something like that. Okay, when it comes out, it's going to go out this way, but it's going to speed up, so it's going to go away from the normal line, right? This is our normal line. It's going to go away from that. Let's undo, oopsies. So it's going to go away from that. That means it's going to, it's going to go that way. Maybe not that extreme, maybe like that, away from the normal line. Okay, so play with a blob and see what happens. Let me do one more. I'll do one more. Let's make it, and let's do a laser red. I'm gonna draw just a random direction here. There's my flat surface. This is my flat surface. Normal line would be 90 degrees to that. Of course, you guys use your post-it note. I'm just trying to not waste your time. It's going into this flat surface, or it's going into this blob this way, but as you know, it slows down when it goes into something more dense, so it's going to head towards the normal line. Here we go, towards the normal line. Do you see the bend? I hope you see the bend. I tried to make it slightly obvious. Okay, so it moved towards the normal line. Okay, this side, find the tangent. It's like that. Normal line is like that-ish. Okay, so it comes out here, but it's going to bend away from the normal line because it's going to speed up in air because it's less dense than what was inside. So we're going to redraw this. When it comes out, it's going to go zing this way. All right, have fun with various shapes. It's all the same thing. Just always draw a tangent line. Always draw your normal lines. Use a post-it note if you're not sure if it's 90 degrees. I can just estimate because I have a lot of experience with this. And then draw your light rays through it. And actually, you can draw shapes that you have around you, shapes of different pieces of glass around you, and then test it with a laser maybe. All right, have fun.